In this nugget, we're going to lab up, capture, and analyze secure shell on an IPv4 network. Let's begin. Someone once told me that friends don't let friends run Telnet, and that's because Telnet is a plain text protocol. And if we're doing remote management of our devices, we absolutely want to do it securely. So Bob, the administrator, if he needs command line access, it's very likely he's going to want to use SSH, which is the acronym for secure shell, instead of raw, insecure Telnet. Bob's computer will generate some high-numbered source port and use that for the individual session going to port 22 on R2. The reply packets going back will be sourced from port 22 as they go back to that source port Bob created. So what you and I get to do is we're going to configure R1 and R2 for basic connectivity. Then we'll set up R2 to support SSH. We'll create a local user account. We'll specify that to log in to R2, we only want to allow SSH, meaning Telnet's no longer going to be allowed. Then we'll capture the traffic on the wire, and we'll use R1 as a client to log into R2 via SSH. So inside of GNS3, let's go ahead and bring up a couple of routers and put them on our topology. We'll have R1 here on the left. We'll bring in a second one for R2. We'll use the link tool, and we'll build a connection. And we'll use Ethernet 1/0 on R1 and 1/0 on R2. We'll also go ahead and use the labeling tools. We'll turn off the link tool, and then we'll start both of those routers. And then we'll open consoles to each one of them. So let's begin at the console of R1. We'll go into configuration mode. We'll go into interface config for Ethernet 1/0. We'll bring it up with command no shutdown. I once had a Cisco dog, and I taught him how to sit by doing a no stand-up command. Next, let's apply an IP address of 10.0.0.1 with a 24-bit mask to this interface, and let's also apply a MAC address, specifically so that when we see it inside of Wireshark and we see all those ones at the tail end of the MAC address, we'll know that that is R1's MAC address. Next, we'll make a road trip over to our good friend Mr. R2. Go into configuration mode and go into interface config for Ethernet 1/0, and we'll do a no shutdown there as well. Let's also give R2's interface an IP address. We'll use 10.0.0.2 with a 24-bit mask, and we'll also use a MAC address with a bunch of trailing 2s for the back 6 hexadecimal characters. When using SSH, we're going to be required to log in with a user account. So let's create a local user in the running config of R2 with the syntax username. We'll create a user called admin. We'll specify privilege level 15, and we'll enable the secret as nugget bang23. Next, let's go into our logical VTY lines. We'll go to line 0 through 4, which is our 5 first VTY lines, and we'll specify that we want to validate logins using the local database. Again, referring to our local config here on this router. Now, by default, Telnet and SSH are both allowed on the VTY lines. If we want to restrict it to just SSH, we can say transport input SSH, and that is one way of eliminating Telnet from being allowed in on the logical VTY lines. Now, SSH does require some keys, specifically public-private key pairs used for SSH. And to generate a public-private key pair, we also have to have a domain name specified. So let's exit out of line configuration mode, and let's create or specify a domain name of cbtnuggets.com. Now, there is yet another way of specifying a domain name, and that is with the command IP domain space name cbtnuggets.com. And routers support current versions as well as legacy versions of commands, and this is an example where this iOS is supporting both flavors. And if you're curious, okay, which one is the current version of the command? Is it domain-name or domain space name? And the answer to that lies in how is it written in the config itself. If we do a do, show, run, pipe, include, domain, the do command is because I'm issuing this command from configuration mode. And the pipe says only include output or only show output where the word domain is included in the line of the config. So I'm going to press enter, and the survey says that the current flavor of the IP domain name command is domain space name. Because even if we used a few up arrows like this and did the command with the domain dash name, if we did the show command again, you'll notice that it's still storing it without the dash. So the legacy version is with the dash, it's being accepted, but it's using the current version of that command in the config itself. Next, let's generate a public-private key pair, and we're going to specify a modulus of 1024. That really should be the minimum that we would specify with any of our cryptography. With cryptography, the bigger the keys, the more secure a protocol is considered. And that's really all we have to do at a basic level for SSH functionality at R2. So to test this, let's go back over to R1. We'll use R1 as an SSH client. We'll put in the syntax SSH-L, the word admin for the user we want to log in as, and the IP address of 10.0.0.2, and then also apply the password for admin. And that username and password is based on the local config on R2, and I'll press enter. And we are now connected via SSH to R2. If we did a show TCP brief, that could help confirm our existing session. So from R2's perspective, it's got its local IP address of 10.0.0.2. It currently has a TCP session to port 22. That's the well-known port for SSH. And this is indicating that it was sourced from 10.0.0.1, which is R1, from the source port number of 57,093. Now, the only negative thing about this SSH session is that we did not capture the traffic between R1 and R2 before issuing it. So let's go ahead and I'll type in exit. Let's go to Wireshark. In Wireshark, let's capture that traffic. We'll say start capture. Click OK. We'll minimize that capture for a moment. Go back to our console port and let's SSH once more. And now we're in. And if we do a show run, that's doing a show running config for R2. And all of this output is being sent from R2 back to the SSH session over to R1, which is where we're viewing it from. So I'll type in exit, and then we'll go ahead and stop our capture. First inside Wireshark, we'll click on stop, and then in GNS3, we'll click on the link and select stop capture. So we'll save this capture, and we'll call it IPv4 SSH, and click on save. And if we go to our very first packet, we have some keep alives from R2 and R1 respectively in packets 1 and 2. And then in packet 3, we have the beginning of a beautiful three-way handshake with TCP. So packet 3 is a SYN request, packet 4 is a SYNAC, and packet 5 is an acknowledgement. And then after the three-way handshake, there's some negotiation that's going on regarding the SSH session between R1 and R2. And if we scroll down further into the capture, and let's grab packet 57 as an example. Because the content is encrypted, we can see on the wire the Ethernet header information, the source and destination MAC address, the layer 3 information, which is pointing to the next protocol, which is protocol 6, which is TCP. We can see the TCP header information, which is the source and the destination ports involved. But as we start looking at the SSH, the contents of that payload is encrypted. So any eavesdropper who's trying to discover the clear text information regarding what's being communicated back and forth won't be able to do so because the eavesdropper, without the proper keys, is not going to be able to decode this information. And that's one of the primary benefits of SSH. In this nugget, you and I labbed up SSH on R2. We connected to R2 from R1, with R1 acting as an SSH client. We captured the traffic, and then we looked at it under the microscope of Wireshark. I have had a great time in this nugget. I'm super glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.